Oh, hello, year 9. This is week 3, and our lesson 5 today is on negative indices. Our learning intention is to understand negative indices and how to use that to simplify algebraic expressions. Success criteria will be looking at expand and simplify, and also application of all the index laws in assisting us simplifying algebraic expressions. Let's start with a warm-up. This is a 7 dividing fractions skill that would come handy with today's lesson. So I have chosen as a warm-up task 1/9 divided by 3. Now in year 7 you would have learned 2 different strategies for dividing fractions by whole numbers or dividing fractions by fractions. Now as we set out to do this task, what I want you to keep in mind is that the whole number 3 can be rewritten as 3 divided by 1. Now, when we divide fractions, one of the strategies is keep, change, and flip. Flip means we have to turn this second fraction upside down. So we have 1/9 multiplied by, instead of 3/1, it becomes 1/3. And as with fraction multiplication, you multiply your numerators and we multiply the denominators. And that simply gives us 1 times 1, which is 1/9 times 3, which is 27. So our final answer is 1/27. But since we're dealing with index numbers, I'll intentionally write our final answer. Remember, 1/27 is the same as 1/3 times 3 times 3. So I'll write this as 1/3 to the power of 3 as our final answer. We'll see its use in our lesson today. Thank you. So let's move on. When we discussed the 0 power, we had something similar like this to observe the pattern. So we are applying the first success criteria, which is expand and simplify, to what we have here. Now, 2 to the power 4 is 16, and we know 16 divided by 2 is 8. So 8 divided by 2 will be what? 4. Another way of knowing that is 2 squared is 2 times 2, which is 4. And if we continue and we divide again by 2, 4 divided by 2 will give us what? 2, which is the same as 2 to the power of 1. And as we saw with the 0 power, we know that we divide again by 2 because that's the pattern and we don't expect the pattern to stop. So because we had 16 divided by 2 gave us 8, divided by 2 gave us 4, 4 divided by 2 gave us 2. So 2 divided by 2 give us what? 1. And so we do know that 2 to the power 0 is 1. Now, would the passing stop from there? Of course not. So what we need to do is to divide that result by 2. And 1 divided by 2 is 1/2. So it tells us 2 raised to the power of -1. 2 raised to the power -1. is the same as 1 over 2. What about 2 raised to the power minus 2? Well, that has been done for you. When you divide half by 2, you get 1 over 4, which is the same as 1 over 2. How do we know 1 half divided by 2 gives us a quarter? Well, that's why we did a warm-up today. So you have half divided by 2. So this is the same as half divided by 2 over 1. Remember, keep, change, and flip. So this is equal to half multiplied by the division becomes multiply, and the 2 over 1 becomes half because we turn it upside down. That goes up, that comes down. And half divided by half is 1 times 1 over 2 times 2, which is 1 over 4, but we can also keep it as 1 over 2 times 2, that's 2 squared. That's why we have that as our result. So you can see logically 2 to the power minus 3 will be this 1 over 4 divided by 2 again, and that gives us 1 over 8, which is the same as 1 over 2 to the power of 3. You can work that one out. 1 over 4 divided by 2 is the same as 2 over 1. So if we do keep, change, and flip, you have 1 over 4 multiplied by 1 over 2, and that is equal to 1 over 8, which is also the same as 1 over 2 to the power of 3. So basically what we're saying in this slide is if you keep dividing by 2, you get to understand the 0 power. That 2 to the power 0 is 1. And if you go beyond that, we get into the negative part. 2 to the power minus 1 is simply half. 2 to the power minus 2 is a quarter, or 1 over 2 squared. And 2 to the power minus 3 is 1 over 8, or 1 over 2 to the power 3. And you can see a mirror image. You see this to the left hand side here, you have 2 to the power 1, that's 2 to the power minus 1. You have 2 to the power 2, that's 2 to the power minus 2. That's 2 to the power 3, that's 2 to the power minus 3. And this 8, that's 1 over 8 over there. That 4 is 1 over 4 here. This 2 is 1 over 2. So to the right hand side, you see more or less like a mirroring of the left hand side. Not exactly, because this becomes the reciprocal, because this becomes negative on the right hand side. Right, let's have more practice. So you can pause the video here and do this activity yourself. So if you can pause now, that would be great. Thanks. I hope you've paused and you've been able to do that yourself. So let's carry on. So again, you can see 81 divided by 3, that gives us 27, which is the same as 3 to the power of 3. 3 squared will be what? 9, which is the same as 27 divided by 3. So the pattern continues. So to find the next one, we divide by 3. 9 divided by 3 is 3, which is the 3 to the power of 1. Will the pattern stop? Of course it's not. So we divide by 3 again, and 3 divided by 3 equals what? 1. So it tells you that 3 to the power of 0 is 1, as we realized from the 0 power in our previous lesson. Any number raised to the power 0 is 1. Any non-zero number raised to the power 0 is 1. Right. Since the pattern is not stopping, we divide by 3 again. And 1 divided by 3 gives us 1/3. And 1/3 divided by 3 again will give us 1/9, which is 1/3 squared. And again, that divided by 3 again will give us 1/27, which is the same as 1/3 to the power of 3. This is the example I did as a warm-up, where I did 1/9 divided by 3. That gives us 1/3 to the power of 3. I'm sure this is what you also got when you did the table. Let's have one more practice. One more practice. 10 to the power 4 is 10,000. If you divide by 10, you get 10 to the power of 3, which is 1,000. You can pause here and continue and work through that, and we will fill the table together shortly. Thanks. So you would have continued by saying divide by 10, and 1,000 divided by 10 is 100, which is the same as 10 squared. Then 100 again divide by 10, that gives you 10, which is the same as 10 to the power of 1. And of course, you divide again by 10. You get 10 divided by 10, which is 1, which is at 10 to the power of 0. As we've seen, any non-zero number raised to the power 0 always gives us 1 because it's the number divided by itself. And that 1 divided by 10 would give us 1/10. And 1/10 divided by 10 will give us 1/10 squared, which is 1/100, which is 10 squared. And 1/100 divided by 10, that gives us 1/1000, which is 1/10 to the power of 3. So you have from 1, you have 10, 100, 1,000, 10,000 to the left, and to the right, you have from 1, you have 1/10, 1/100, 1/1000, 1/10,000, and so on. It will continue the same pattern. Right. Before we state the law, the negative indices law, let's do one more activity. I have a squared divided by a to the power of 5. A squared divided by a to the power of 5. That is simply a squared is a times a. I'm using expand and simplify. And a to the power of 5 is a multiplying itself 5 times. Right. So if I do that, this a will cancel that a, give you 1 and 1. This a will cancel that, give you 1 and 1. And so I have this being equal to 1 times 1 at the numerator divided by a times a times a, because 3 of them are remaining. And this is simply 1/a to the power of 3. 1/a to the power of 3. That is using expand and simplify. Now, if I use index law 2 and apply that to a squared divided by a to the power of 5, since the bases are the same, I'm simply subtracting the powers. And this will be equal to a to the power of minus 3. Since these two answers are the same, I can conclude that a to the power minus 3 is the same as 1 over a to the power of 3. I can conclude that a to the power minus 3 is the same as is the same as 1 over a to the power of 3. So that's the conclusion we reach here. And this is our negative indices law, that a to the power minus 3 is equal to 1 over a to the power of 3. So let's look at the law in general terms. So in general terms, any non-zero number a raised to the power minus m is going to be the same as 1 over a to the power of m. So generally, that is the law, negative indices law. The a obviously got to be a non-zero number. That will be seen in further studies in maths at a higher level. Right. So how do I apply this law to a question like x to the power minus 2? Well, since I know that a to the power minus m is equal to 1 over a to the power of m, x to the power minus 2 is equal to 1 over x to the power 2, positive 2. As simple as that. As simple as that. How do I change this? Well, this is equal to, remember, I've got 3 multiplying a to the power minus 2 times b to the power of 4. But I know that a to the power minus m must be equal to 1 over a to the power of m. That's the law I am applying. So this will be 3 is simply 3 over 1, remember, as a fraction. And a to the power minus 2 is simply a 1 over a to the power of 2. And I'm multiplying this by b to the power of 4 over 1. I can multiply all the numerators together and all the denominators together. So I've got 3 times 1 times b to the power of 4, all divided by 1 times a squared times 1. 3 times 1 is 3, and multiplied by b to the power of 4 becomes 3b to the power of 4. And we're dividing this by 1 times a squared times 1, that is simply a square. So that is my answer. 3b to the power 4 over a squared. So this simplifies to 3b to the power of 4 all over a squared. That's what that is equal to. Right. Again, I can let you do this by yourself, and then we can discuss. Remember another way of writing this, knowing that c to the power minus 2. So you got 1 divided by c to the power minus 2. But I know in general, a to the power minus m will be equal to 1 over a to the power of m. That's the law I am applying. That's our success criteria here. So I can write this as, now 1 is simply 1 divided by 1. And I'm dividing this by c to the power of minus 2, which becomes 1 over c squared. Remember, keep, change, flip. So I have 1 over 1 multiplied by c squared over 1. I have to invert, flip that, because I changed the divide into multiply. Then I can multiply the numerators together, which will be 1 times c squared over 1 times 1. 1 times c squared is c squared. And 1 times 1 is 1. So this is simply c squared. So what I can say is that 1 over c minus 2 is simply equal to c squared. Simply equal to c squared. 1 over c minus 2 is equal to c squared. Right, be very careful and be patient with that. This is equal to, now, so keep in mind a minus m is equal to 1 over a to the power of m. So if you separate these things, you've got x to the power minus 3 times 1 over y to the power minus 5. So that would be equal to 1 over x to the power of 3. And you're multiplying this by, now, at the bottom here, you also have 1 all over, and y to the power of that is going to be equal to 1 over y to the power of 5. So this is simply 1 over x to the power of 3 multiplied by y to the power of 5 divided by 1. This would go up. And so that becomes y to the power of 5 over x to the power of 3. So x to the power minus 3 divided by y to the power minus 5 is equal to x to the power of 5 over x to the power of 3. X to the power of 3. Any questions? 3 to the power of minus 4. Without using a calculator, Let's work out what that value is. Well, this is very simple. Again, we're applying the law a to the power minus m equals 1 over a to the power m. So this is simply 1 over 3 to the power of 4, and this is equal to 1 over 81, because 3 to the power 4 is 1 over 81. So that's what you get. 3 to the power minus 4 is equal to that. Okay. Five over 3 to the power minus 2. Now, this is equal to minus 5 multiplied by 1 over 3 to the power minus 2. Now, think of a to the power of m is equal to 1 over a to the power m. This also tells you that a to the power m will be equal to the same as 1 divided by a to the power minus m. That's to make it much easier for us. So that's another way of writing that law there. So looking at this, you can do it like the way I did it in the previous slide, or we can apply the rule and do it straight away here, which is minus 5 times 3 to the power of 2. And minus 5 times 3 to the power of 2 is simply minus 5 times 9. Now remember, negative times positive will give us a negative result, and 5 times 9 is 45. So minus 5 over 3 minus 2 is simply that. That's minus 5 over that. That gives us minus 45. It's minus 45. Right, be careful again with this. So this is simply 2 to the power minus 4 over 3 to the power minus 4 if you're using index law, I think it's index law 3. So in this case, you can also see that by writing it this way and thinking of a to the power of m being equal to 1 over a to the power of minus m, which I introduced, and a to the power minus m being equal to 1 over a to the power of m. Thinking about these two, we'll be able to use this to assist us so that let's write this way: 2 power minus 4 over 1 multiplied by 1 over 3 to the power minus 4. Now, if you think of this part here, you are thinking of that. So that part becomes 1 over 2 to the power of 4 multiply. Now, if you think about this part here, and you look at this, then it tells you this part becomes 3 to the power of 4 divided by 1. And so this is equal to 3 to the power of 4 over 2 to the power of 4. 3 to the power of 4 is 81, and 2 to the power of 4 is 16. So that's your answer. So 2 over 3 all to the power negative 4 is 81 over 16. It's 81 over 16. Just take your time and have a look at it, because one way of writing this law is that they are the same. So you can use both to address your needs. You can pause here, write all the questions down in your math books, solve these questions showing you're working out, apply all the laws that we have learned to date. Apply all of them. You do the same on this page. You pause and copy the questions in your math books and show you're working out. Please. Now, you can pause and do this yourself first and compare with my answers or with my working out. Right. So 2 to the power of x equals 1 over 16. Now we apply our knowledge of how to solve equations also to help us do this. Now, one thing you'll notice is that 16 can be written in terms of 2. So that's the initial step or the initial strategy, so that the bases are the same. We want base 2 in this problem. So 2 to the power of x is equal to 1 over 2 to the power of 4, because I can write 16 as 2 to the power of 4. Remember, 2 times 2 times 2 times 2 is 16. Because this 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. So we've not changed the question. Right. Now, if you think of negative indices, then we do know that a to the power minus m is equal to 1 over a to the power of m. And applying that to this part, I can write 2 to the power of x. 2 to the power of x is equal to 2 to the power of minus 4. Since bases are the same, bases are the same, therefore powers are the same also. Powers are the same also. So I can simply equate x equals minus 4. And that's my final answer. The bases are the same, so the powers are the same. Easy done. Again, you can pause, solve this problem first, and then we can do it together. Can pause and we can do that together. Okay. I hope you've paused and you've done it so we can discuss. Well, 243. we know it's divisible by 3. Let's try and divide 243 by 3. 243 divided by 3 will give us 81. So we know that an 81 is also multiples of 3. So we can write 3x plus 1 equals 3 to the power of 5. Remember, 81 is 3 to the power of 4, and since 243 divided by 3 was equal to 81, because 3 into 24 will give you 8, and 3 into 3 will give you 1. So it was very easy. And why are we choosing 3? Because the base there is 3, so our strategy is to use base 3. So we can equate powers. So this is the most crucial step. Once you've been able to write this, bases are the same, because on both the left-hand side and the right-hand side are the same. Therefore, powers are equal. So I can write the next step, which is x plus 1 must be equal to 5. And then solve this problem, which is a very easy one indeed, because I need to subtract 1 here and subtract 1 there. So this side becomes x equal to 5 minus 1 is 4. 5 minus 1 is 4. So that's your final answer, and it's easy done once again. So thank you very much, Year 9, for your participation. Today we looked at negative indices. And our learning intention was to understand negative indices and how to apply this to simplify algebraic expressions. We looked at, as our success criteria, expand and simplify, and we also looked at applying all the index laws we've learned to help us simplify algebraic expressions. We made use of a lot of the skills that we already have, like how to divide fractions and also how to solve equations. Right. It is my expectation that you will complete all the practice questions in this video in your maths books, and you'll show all the required working out. And you also mark your work, because I've provided answers at the end of this video. So you mark your own work. You don't have to upload it back, but you mark it and keep it as your personal record for the lesson. Additional work is set on your online homework, which is Education Perfect. I'm currently aware that it's not been working, is being down. We'll get some information and communicate to you in Google Classroom. In the meantime, you should also note that the online homework on Education Perfect is optional. That is, if you do not have the time to do it, it's okay during this time of remote learning. But those individuals who have extra time to catch up with more skills in maths, please, by all means, go ahead, do as much as you can. You don't have to do everything which is there, you just have to do what you can do. Thank you very much. If your answers to the questions in today's video are different from the answers provided at the end of this video, then please post your questions on Google Classroom and I will answer them. Do that more or less during the math lessons. That will be beneficial for other students as well. Thank you very much. And if you have time, please, you can also subscribe to my YouTube channel videos, which I normally upload from time to time, so you can get a notification once I upload. Thank you very much. The channel is Tabi Maths. Right. these are the answers to the various questions that was posted today. So you can use the slide to mark your work. If you've not done the work, you can exit from here now, go and finish the work before you look at these answers. This is just to help you mark your work. Again, these are answers to some of the problems that we gave.